So absolute value functions are also referred to as modulus functions. And modulus looks something like this. And anything inside the modulus turns out to be positive. Let's say, for example, I have minus 3 inside the modulus. So this will turn out to be 3. What if I have minus 9 inside? This will also turn out to be 9. Similarly, if I had 3 inside the modulus, which is already positive, this will turn out to be 3. And if I had 9 inside the modulus, this will also turn out to be 9. So, what if I have x inside the modulus and it's given at this equals to 5? So, x can either be 5 or x can be minus 5. Thus, this can be written as x equals plus minus 5. Similarly, what if I have x equals 2? This can be written as x equals plus minus 2. Since there exist two possibilities for it. And let's say I'm given that x minus 3 inside the modulus equals 7. So in this case, the first step will be the same. I'll write x minus 3 equals plus minus 7. So now I have two equations. I'll write both the equations separately. The first equation will be x minus 3 equals 7, and the second equation will be x minus 3 equals minus 7. So the first equation will give me the value of x as 10, and solving the second equation will give me the value of x as minus 4. So both these values are the answer. Now do keep in mind that this equation can also be solved by squaring both sides. And you square both sides to remove the one. So you need to understand this carefully. I repeat, to cancel the square root, we square both sides. But to remove the modulus, we also square both sides. But to cancel the square root and to remove the modulus, there is a difference. So in case of a square root, we square both sides, and the square cancels the square root, and x turns out to be 9. But in case of a modulus, to remove the modulus we also square both sides, but the square cannot cancel out with the modulus. Instead, we only square both sides to remove the modulus. The square will still remain, and we'll get x square equals 9. And then we'll square root both sides, and we'll get two values of x, and the two values of x are plus minus 3 and minus 3. So to clarify this, let's take another example. Let's say I have x minus 1 inside the modulus and equals 3. So first of all, let's square both sides. So after squaring both sides, I have x minus 1 whole square equals 9. So now I'll square root both sides, and I'll get x minus 1 equals plus minus 3. And this gives me two values of x, which are x minus 2 and x is 4. There also exists an alternative method, which we learned earlier. That is, if we have x minus 1 inside the modulus, we can use the simple plus minus technique in this case. So we have this, and we get the same values of x again. So when can we only use the squaring both sides technique? So if we have a modulus on both sides, and that example would, or rather question will look something like this: 4x minus 3 inside the modulus equals 2x plus 1, and also inside the modulus. So how do we solve this? We have a modulus on both sides, so we'll square both sides. It's not advisable, or rather not let it's not advisable to use a plus sign. So once we square both sides, we have 4x minus 3 whole square and 2x plus 1 whole square. We'll expand this using the identity. So we have 24x plus 9 equals 4x square plus 4x plus 1. Then we bring everything to one side. So we have 12x square minus 28x plus 8 equals 0. We can simplify this by taking 4 common, and this turns out to be something like this. 4 goes on that side, and so we have this as the quadratic equation. We'll factorize this, and the factorized form would look something like this. And the two values of x which we get would be x equals 2, oops, and x equals 1 over 3. So let's take a second example too. Let's say we have 2x minus 5 inside the modulus and 3x plus 1 also inside the modulus. Since we have modulus on both sides, we have to square both sides again. We'll apply the identity. So we have 4x square minus 20x plus 25, since we remove the modulus. And then on the right hand side we have 9x square plus 6x plus 1. We bring everything on one side, so we have this. We'll break the middle term as 30x and minus 4x. Now we can factorize, and the factors look something like this in the factorized form, and the two values of x in this case turn out to be x equals 4 over 5 and x equals minus 6. So what if we're given something like this, where we have expressions on both sides and modulus only on one side? So in this case, you can apply either of the plus minus technique or squaring both sides, but since we only have a modulus on one side and expressions on both sides, it is essential to check the validity of terms. Like for example, in this case, we had modulus on both sides, so we don't need to check the value. In this case, we only had one expression on one side, and that side also had modulus, so we don't need to check the validity of it. But in this case, we have expressions on both sides and modulus only. We need to check the validity of it. So let's solve this by using the plus minus thing. So we can write this as 4x minus 5 equals plus minus 2x plus 1. Is that right? Yeah. We can write this as two separate equations. So as 4x minus 5 equals minus 2x minus 2x plus 1, and as 4x minus 5 equals 2x plus 1. So we can write this as 2x equals 6 and x equals 3. So we have one value. For the second value of x, we can write this as minus 2x minus 1 and decide as it is. So we have 6x equals 4 and x equals 2 over 3. Now, to check the validity of the answers, remember to write the subheading. So you always remember to do so. Check validity. So we'll check the validity by substituting the answers back into the equation. So we'll write this as into the original equation. Keep in mind. So we have 4 multiplied by 3 minus 5 modulus equals 2. It's 2x, so we write this as 2 into 3 plus 1. And we have 7 equals 7. Thus, the left hand side equals the right hand side, and this answer is valid. Now, for the second answer, we'll do the same thing again. So, 2 over 3 minus 5 whole modulus, and substitute it on the right hand side, and we'll get minus 7 over 3 modulus equals a 7 over 3 modulus, and this turns out to be positive since this is inside the modulus. So left hand side equals right hand side, and this answer is also right. You will have to reject any of the answers if the right hand side is not equals to the left hand side. Let's take for example, this will be our last and final example for this class. So again, we have two expressions on both sides, but a modulus only on one side. So we'll solve this as we always do. So we have 2x minus 5 equals 3x minus 2, and we have 2x minus 5 equals minus 3 minus outside the bracket and minus 2. So, and why did we do this? Because 2x minus 5 equals plus minus 3. Alright, so solve both sides, and we have minus 3 equals, so we have x equals minus 3, and solving the second equation will give us 5x equals 7, so x equals 7 over 5. We check the validity again. We check the validity by substituting both the values separately into the original equation. So we have something which looks like this, and we have minus 11 modulus equals minus 11, and this turns out to be 11 equals minus 11, and 11 is not equals minus 11. Thus, we reject this value. Now, check the validity of the second answer. We'll do it using the same technique. Y equals, and always remember to use the original equation. So this turns out to be minus 11 over 5 inside the modulus and 11 over 5. So since this is inside the modulus, this will turn out to be positive. Thus, the left hand side equals to the right hand side, and this is valid. So when you leave your final answer, remember to only leave 7 over 5. and not the first. And always remember to write rejected.